Now we start our second lecture today, and we continue. In the first lecture, we went through the basic concepts of probability, and we mentioned that probability theory is the mathematical branch which gives some quantification for the uncertainties. So to describe some uncertainties, we need this probability theory to give us some quantification or some numbers representing the uncertainty involved in any process. And also we mentioned in the previous lecture in details why this probability theory and the stochastic process is very important in many different applications. Today we can go a little bit further and we go to the next part, which is the conditional probability. So the conditional probability is a very important advancement in probability theory because it gives us some concept how the knowledge of certain event will affect another event or the uncertainty of other event. So it is very important in that sense because events in reality, they are correlated. They are dependent on each other. So in order to study any uncertainty, we need to see the other parameters or the other events which depend on each other or correlate to each other. So now you can see, for example, in this equation, this is very simple, but at the same time, very important. This is one of the pillars of probability theory. It says that the probability, I will just put it again. So the probability of event B, given that event A has occurred. So what is the probability of event B if we have another event, we named it as A, has already occurred? This says that this probability is equal to probability of A and B divided by probability of A. So this is the way that we can compute it. Of course, we can prove it at least based on Venn diagram, as we will see later in the next slide. But here we need to understand what this equation means. This equation is very important. For example, if you have any event B, and we have another event A, what is the impact of A on the occurrence of B? If you have, let's say, the relation between the temperature and the black off, what is the probability that we will have black off in electricity given that the temperature is greater than, for example, 45 degrees? They are related. So now we have this condition. It is called conditional probability because events, they are in general, they are not independent. They have some dependency among each other. So this equation will describe to us how to quantify the probability of certain event given that some other event has occurred. This form can be approved at least intuitively based on this figure. So we have here the event A, and here we have event B, and this is A and B. So what is the probability of A given B? So B has occurred, this B. So this probability that A has occurred equal to the probability of A and B. You can look to it as the area, probability of A and B divided by the probability of all B. We will see many examples about this, and we will see also some real problems that we can analyze them and see how to resolve these. Like some of them, they are very complicated from the beginning, but when we look to them based on this conditional probability, we can find very a straightforward way to find the solutions. Okay, so we have certain nice and interesting conditions that it can be based on this conditional probability. Before we go further, let me Now maybe the screen is black. So now we know that we said that probability of A given B equal to probability of A and B. Sometimes probability A and B, we call it as AB. So it seems the same, divided by probability of B. Okay. If A and B are independent, if A and B are independent, so A and B are independent events. Okay, so what is the probability of A given B? Sorry. What is the probability of A given B? What do you think? What is the probability of A given B if A and B are independent to each other? In this case, if B is independent of A and A is independent of B, then the occurrence of B will not affect in any way the occurrence of A, because A and B are independent. So since they are independent to each other, then it doesn't matter if B has occurred or not occurred. So A and B will be independent of each other, and in this case, the probability of A given B is the same as probability of A. Because if you know B has occurred or B didn't occur, this will not affect anyway our uncertainty about A. Okay, so in this case, this is the condition that A and B, they are independent. Okay, since probability of A given B equal to probability of A, now we substitute this in the previous equation. Then what we got that probability of A and B equal to probability of A times probability of B. And this result is correct or is true if and only if A and B are independent. So you have to remember this one. So probability of A and B equals to probability of A times probability of B if and only if A and B are independent. Okay, if they are dependent, then probability of A and B, if you multiply by this cross multiplication, then probability of A and B equal to probability of A given B times probability of B. So this is the general form of probability of A and B. But if A and B are independent, then probability of A and B equal to probability of A times probability of B. Okay. Yes. The second properties that we can observe from this equation, that probability of A and B equal to probability of A B. Remember that probability AB is the same as probability of A and B. So just for simplicity, we will use this like AB divided by probability of B. So what if A and B are mutually exclusive? You remember from the previous lecture when we talk about mutually exclusive events, it means that if one occurred, the other one cannot occur. So they are impossible to occur in the same time. Like flipping the coin. Flipping the coin, you will get head or tail. But it is impossible for a normal coin that you will get A and in the same time you will get B, because A and B are mutually exclusive. And in this case, probability of A and B equal to 0. If they are mutually exclusive, then probability of A and B, this one will be 0. And in this case, probability of A given B has occurred will be 0. So this is for mutually exclusive events, that events cannot occur at the same time. So you need to remember this one. Okay. Now we come to another very interesting properties here. Okay. So we said that probability of A given B equal to, just maybe we can change the color. Maybe white is better. Yes. Probability of A given B equal to probability of AB divided by probability of B. And probability of B given A. What happened if you just swap between A and B? This one. Simply the above, because probability of AB is the same as probability of BA. So in this case, it will be the same. But here we will have probability of A. Okay. And if you multiply by cross multiplication, and then we will have here probability of AB, this equal to probability of B given A times probability of A. And if we substitute this one in the first equation, then we got probability of A given B equal to probability of B given A times probability of A divided by probability of B. So actually this equation is very well known in, it is called Bayesian equation. And this one is very, very important equation in estimation theory, in probability analysis, also in machine learning, in it is called also Bayesian inference, Bayesian reasoning, a lot of applications in machine learning and artificial intelligence in estimation theory. This equation is one of the most important equations that we will see how it will affect, and in a few in the subsequent like sessions, you will see the applications of this equation. So probability of A given B equal to probability of B given A times probability of A divided by probability of B. So, but let us think about a little bit like going deeper to understand what this equation means. So with, of course, this will be clear when we'll see some numerical examples. But before that, it says that if the probability of event A to occur, okay, given that probability of B has occurred, so our dependency between A and B also depends on what is the probability of B that A has occurred. So in other words, what is the knowledge that we got from the occurrence of another event on our uncertainty about certain event. So now we have certain event A, and you have been informed that another event B has already occurred. So how this will affect your uncertainty or your certainty about the probability of A to occur or not. So this depends on the probability, okay? It is just swapped. The impact of B if A has occurred. I know that this could be a puzzle right now for you, but let us take simple example. At certain day, I will keep it with this blackout in electricity and also the temperature, because it seems that it is clear, like example that to imagine. So now, in certain day, we have that B is the temperature. So B is the temperature. So the event that this temperature becomes a high humidity and the temperature is greater than 45 degrees. When the temperature is greater than 45 degrees, what is going to happen? That everyone will just switch on their air condition, and also the high humidity in the air. It might cause also some problems in the transmission lines and transformers and so on. Okay, so everyone working in electric electrical utility or in electrical in the general electrical company in Libya, they will start to feel that there is some probability or there is higher chance that they will get blackout. And then they start to take care, they start to collect a lot of information from the sensors. They start to have just plant planned cut for certain areas. They are preparing to avoid the blackout. Why they start? Because they know that when B has occurred, then there is a higher chance for A to occur. We know that. Okay. But what is the probability if we need to know the value? What is the probability that this will occur? We can use this equation. For example, this is called the likelihood equation, and looking to the probability of B given A. What that mean? This means what is the probability that the temperature was greater than 45 given that blackout has occurred. Okay, from where we got this probability? We got it from history. If now you go to the record of GCOL, of the General Electric Company in Libya, if you go there, and there is a record for all blackouts happened. For example, let's say in the last 10 years, okay? And assume that during the last 10 years, assume that we got 60 blackout, for example, okay? I think the number is less than this, but just example. So we have now 60 blackout happened in the last, let's say, 10 years, okay? And we have list, of course, when the blackout happened. Also, there is parameters there. So I am now looking that how many times out of 60 the temperature was greater than 45. Then I found that out of 60 the temperature was greater than 45 40 times. Then the probability of B given A equal to 40 divided by 60. Okay, so it is 2 divided by 3. So now I know this value. Okay, what is the probability that we got a blackout? For example, it was 60 times that we got blackout in 10 years. For example, 10 years is 3,600 days, for example, and then we have 60 times. So it is 60 divided by 3,600. This is the probability of A. What is the probability that the temperature is greater than 45? I checked during the last 10 years, how many days the temperature was greater than 45. Assume that this was like 100 days. Then this will be 100 divided by 3,600. This probability of A will be 2/3. Probability of B given A, it was 2/3. Then I can easily compute what is the probability that I will get today a blackout. And according to this value, I can like take the process. What process that I should take? Of course, this will be done by the decision maker in the electrical company. So the decision maker, maybe they have some threshold. If this probability becomes greater than 70%, then very like aggressive action must be taken in order to avoid the blackout, for example, or greater than 80%. So by this way, we can compute what is the probability of A given B. So you can see that how useful this equation. It is very useful, not only here, in medical science, in telecommunication, everywhere you can find these equations. Okay? Now, let us continue. If you have questions, you can write them on the chat, or you can also ask me immediately. Okay. If there's a question I didn't hear, so it is better to write, because yeah. Okay. Yeah, so this is what here we have some few examples about the application of this probability. For example, here assume 9 cards, that you have 9 cards. Okay, I just write here. Okay, so now you have 9 cards with numbers. So each card has number from 1 up to 9. Okay, one card has been drawn randomly. So you don't see the numbers on cards, so it was flipped down. So just you select one card in random. Find the probability that the card is numbered 9. Of course, because they are equally likely, so every one of them should be 1 over 9. The probability of each one, we explained this in the previous lecture, because we assumed here that they are equally likely. So the probability of each one of them will be 1 over 9. So in this case, the probability that you will get 9 is just 1 over 9. Then, what is the probability that it is greater than 8? Given it is odd. Okay, given it is odd. What is the probability that it is greater than 8 given it is odd? If it is greater than 8, of course, we have only 9. Okay, and 9 is odd. So in this case, we can define that to make it according to the equations that we have seen. So the probability that it is greater than 8 will be 8, and it will be only 9 that we will have. And in this case, this probability will be 1. The probability to be that it is odd, it will be 1. That if the question is what is the probability that it is odd, given that it is greater than 8, but the reverse is not 1. The reverse is equal to 1 over 5, because if it is odd, what are the odd numbers here? We have 1, 3, 5, 7, and 9. This is the odd number. So given it is odd, so we have how many numbers here? We have 1, 2, 3, 4, 5, and then the probability that it is 9 equal to 1 over 5. But if it was reversed, the question, it was reversed, that what is the probability that it is odd? Given that it is greater than 8, this probability is equal to 1. So in general, I can write something here important. In general, it is possible that probability, it is possible that, sorry. That probability of, if the probability of A given B equal to 1, it means that B is subset of A. But it does not mean, it is not necessary that probability of B given A equal to 1. It is not necessary. If probability of A given B equal to 1, it is not necessary that the converse is also true, that probability of B given A equal to 1. It is not the case, and this is one example. So the probability that it is greater than 8, given that it is odd. Given that it is odd, it means that B. So now B equal to, or here we call it Y, equal to 1, 3, 5, 7, 9. And then the probability of X given Y is equal to 1 over 5. But probability of Y given X equal to 1. Okay, so we will see more examples about this, but let us go further. This is the Bayesian theorem that we mentioned right now. Okay, and also here, if we have such relation where we have, as you can see, certain sample space, and this sample space is partitioned by mutually exclusive events like B1, B2, B3, and so on. And then we have certain event A, which can be shared between all these subsets, like mutually exclusive subsets. Okay, so the probability of A, actually, before we go to the probability of A, let me explain one thing here. So actually, A itself equal to what? A itself is the same as A intersected with B1. A intersected with B1. Or A intersected with B2, this one. A intersected with B2. Plus A intersected with B3. Because A is consisting of all these intersections. Okay? So now, probability of A is the same as probability of A and B1, or probability of A and B2, or probability of A and B3 until A and up to A and B6. So in this case, go here. So probability. Okay, better to change the color. Okay. So, yes, what happened? Then we have probability of A is the same as probability of A and B1 plus probability of A and B2 until probability of A and Bn. If we assume that the sample space is partitioned by n different subsets, like disjointed subsets from B1 up to Bn. Okay, now from Bayesian theorem, or also from conditional probability theorem, we know that probability of A and B1, for example, equal to probability of A given B1 times probability of B1. Okay, then we can substitute this, or we can put here I. So for any I, for any B, B1, B2, B3, it is the same. So if we substitute it here, we will have probability of A equal to probability of A given B1 times probability of B1, or probability of A or and given B2 times probability of B2, and so on. So in general, we can say that probability of A equal to summation from I equal to 1 up to n. Okay, we look to this. So it is probability of A given Bi times probability of Bi. This is called the law of total probability. So as also we will see later, that the probability of any event A can be computed by it is like projection over different other events, as far as the other events, they are all mutually exclusive or disjointed. Okay. Yes. This is what we have seen now, because this one, it was probability of Bi given A equal to probability of A given Bi times probability of Bi. This is known from Bayesian theorem, and here should be divided by probability of A. But the probability of A, as we show now, is the summation of the projection of this A over every like subset Bi, where Bi's, all Bi's, they are mutually exclusive or disjointed events. Okay, so this marginal probability, it is almost the same concept, almost, but now we can also skip this one. Okay, now we have different examples, but before I go to the examples, I like to show to you some few concepts about the simulation. As I promised you in the previous lecture, that we will see how could we use computer in order to quantify these uncertainties, and how to compute the probability based on computer simulation. It is very important, and actually those they are equally like important. First, to know the concepts of uncertainty and probability, and second, how to apply these concepts in your study, in your research. So this is what I am now going to share with you. So I will stop sharing the lecture or the slides, and I will share the a minute, because I use two screens, so computer sometimes. there is a question here in the chat that if I selected 100, yes, actually I selected 100 as just as example. So it depends on the data that you have, but it is just example, okay? To explain how we can use this Bayesian equation, okay? Now I will share the Octave. See. Can you see it now?
أنا كتبت لك already يعني بس الفقرة اللي نحن فيها السؤال. أنت لما خديت probability من درجة الحرارة خديتها 40%، بينما لما خديت الانقطاع نتاع الكهرباء من 60 من 3600 يوم في ال10 سنوات. فالمية بس أنا يعني I'm missing ليش خديت 100؟ ليش ما خديناش في نفس الفترة من الأيام في نفس ال10 سنوات؟ لأنك أنت لما ذكرت المثال 40 مرة في ال10 سنوات صار لنا مثلا ارتفاع في درجة الحرارة فوق ال 60 أو 75 وعندك الكهرباء انقطعت أو البلاك أوت صار 60 مرة 60 تايمز. تسمع فيه دكتور؟
أنا أسمع فيك نعم. تمام.
فانت ليش يعني هنا شويه صار لي كونفيوز يعني لما انت قلت عالميه ليش ما اخترناش نفس عدد الايام اللي صار فيهم البلاك اوت لان احنا ندرسه في ال10 سنوات.
لا هو الاكزامبل اللي ضربته ان ركزوا معي ان في كل الاحوال حنشتغلوا على ال10 سنوات هنا 3600 مثلا يوم، تمام. فلما شفنا لقينا شنو احتمال صار عندنا بلاك اوت given ان درجه الحراره كانت اكثر من 45، تمام. فلما شفنا الهيستوري لقينا ان صار عندنا اوريدي 60 بلاك اوت في كم؟ في ال10 سنين. لقينا 40 منهن بسبب او 40 منهن كانت درجه الحراره فوق ال 45. فهنا 40 على 60 هذه البروبابيلتي اوف بي جيفن اي، تمام. بعدين الثانيه اللي probability of A probability of B هن الاثنين المفروض نقسموا على 3600، هن الاثنين نقسموا على لكن الحاله الاولى مثلا فرضنا ان صار عندنا مثلا 100 يوم كانت درجه الحراره اكثر من 45، 100 في العشر سنين، فتقعد 100 على 3600. الاخرى قعدت مثلا طلعت عندنا بلاك اوت احنا قلنا 60 صح؟ فتقعد 60 على 3600، ال 3600 تمشي مع 3600 فتقعد 60 على 100.
تمام.
واضح؟ لان 3600 حتكنسل 3600 لان واحده قاعده في البسط واحده في المقام. تمام.
هي عمليه تمام.
نعم. اوكي. Now we turn back to the programming. So we have assumed here that I use Octave. Octave is almost exactly the same as the programming of MATLAB. But as I mentioned last lecture, that it is free, it is open source. So actually, I encourage my students always to use these open source codes instead of taking like hackered version of the MATLAB. And I don't also recommend anyone to pay a lot of money for the MATLAB because we have this Octave, which is free already. Okay. MATLAB, of course, is more stable. MATLAB, it has like more update, like at least twice per year. They have a lot of nice toolboxes there, but still, it is very costly for students. They need to pay at least 100 euro for student, and for us as teaching staff, we need to pay around 500. get the license. And of course, we have free version from the university campus. The university, they have it, but the university also paid a lot of money to get the license of MATLAB. This is the reason that I don't like myself to just pay that much money for this programming tool, as far as we have some free options. I know that most of the students, they use this hacked version, but also the concept of hacking the software is, at least for me, it is doubtful that it is from ethical point of view. Anyhow, now this Octave is free, is very nice, powerful programming language. It has also, it came with a lot of packages that you can use. It has also linear algebra package. It has, for example, optimization package. It has a lot of packages. Okay, and the idea that you can use is also very similar to MATLAB. MATLAB, it has one option that that you can use Simulink. Octave doesn't have Simulink, but there is another programming language. Is called Scilab, or Scientific Lab. I will show it also to you. That one, it has also similar like visual programming, like Simulink. They call it like XCOS. I will show it later. Okay, now let us take some simple concepts here about how to find the or how to repeat some simulation. Okay. First, in this Octave, like MATLAB, you can generate vectors. So it is based on vectors analysis. So I will put X here equal to, can you see that, or should I use larger
Yes.
fonts, or is it okay?
If you don't mind, Doctor, use larger than this.
Sorry, I cannot hear you.
Yeah.
If you write in the chat, it will be better.
It's not clear.
It's not clear. Okay. Let me. So now we have X here. Let us X equal to, it is based on vectors, as we said. So if you write like X equal to 1, 2, 3, 4, this will be X. Okay. You can make it also like this will be row vector. If you want to generate like column vector, it will be 1, 2, maybe 5, 8, 9, or 8, 8. So it gives you column vector. So when you put semicolon between them, then you will get column vector. And also you can generate matrix, like for example, if we write A equal to as a matrix, so it will be 1, 2, 3, and 5, 6, 7, and maybe 9, 0, -1. Then this will be matrix A. You can take the inverse of A easily. So it will be, let us call this P equal to inverse of A. So this is the inverse of A. Then A multiplied by B, it will be this 1, 1, 1, 1. It will be the identity matrix. You can also find the eigenvalue, eigenvectors of any matrix, like you can, like A and B, for example, equal to eigen of A. So it gives you, this is the eigenvectors of matrix A and then the eigenvalues. That's this is the way that how it Octave it work. It is very similar to MATLAB, but now I like just concentrate on the probability part. I will not go through the application or the usage of Octave to solve linear algebra and so on. But now in probability or in random, Octave, they use different nice functions to generate random numbers. One of them is generation of a uniform distribution. So we can say, for example, if x, okay, let me first show you that the function. The function is random, is rand. So this random, it gives you the random number from 0 to 1. You can see if you repeat it every time, you can get a random number, uniform random number from 0 to 1. Okay, if you write like rand 2 and 1, it will generate to you like a random vector which has 2 rows and 1 column, as you can see, 2 rows and 1 column. If I write random 2 by 2, it gives me 2 by 2 matrix, which every one is a random number from 0 to 1. Okay, so this rand, it gives you a random number from 0 to 1. Okay, now if I generate a random number consists of like 1,000 or 10,000 number and 1 vector. So it will be 10,000 row and 1 column. So I will put semicolon here because I don't want to see them on the screen this way. So now x, is a vector consisting of 10,000 elements. Each number is random from 0 to 1. Okay, what is the probability that x will be less than 0.5? Or how can I allocate those which has less than 0.5? Okay, now before I go to this one, let me define this y equal to 1, 2, 0, 4, 6, 0. Okay, so now we have this vector. It consists of 1, 2, 3, 4, 5, 6 elements, and we have here 2 zeros. If I asked you to allocate where are the zeros in y, in Octave, you can do it by using find command. So find y equal to 0. Then you can see that it gives you the location. So it gives you the location. So it gives you 3 and 6. It means that the third element is 0 and the sixth element is also 0, as you can see it here. Okay. How many element equal to 0? You can use the command length of find of y equal to 0. So now it gives you the number of elements. So we have 2 elements where we have zeros in this vector. Okay, so remember, find, it gives you the index of the element that you are looking for, and length, it gives you the length of this vector. For example, now we said that x equal to what? X, as you can see, equal to random number consists of 10,000 elements in rows and 1 column. So now if you write what is the length of x, of course it will be 10,000. Okay, how many element of x is greater than 0.5? Then I can do it in this way. So NE equal to, I call it NE. I named it NE. You can name it anything. Okay, NE equal to length of find of x greater than or equal to 0.5. Okay, so now it gives me this NE equal to 4,962 element is greater than or equal to 0.5. Okay, what is the probability that the element is greater than 0.5? Of course, simply you just divide NE, the number where this you are looking for, divided by the total number of elements, which is 10,000, or you can just write length of X. So it gives you, this is the probability. The probability that you got numbers greater than or equal to 0.5 will be 0.4962. Of course, it is very close to 50%, very close to 50%. Okay, now let us look to that you want to make simulation for throwing a coin. Okay, now you want to throw a coin and or flip the coin, and the coin has head and tail. Okay, I like to have, for example, to give some number for head and some number for tail, but it is not 50-50, because now if it is 50-50, it is easy to do it in this way that we did now. Okay, now I want one of them to be 30%, the probability of head, or the probability of tail to be 30%, and the probability of head, I want it to be 70%. What I can do? Okay, now I have X. X is giving me number from 0 to 1. Let me define Y, and Y equal to 0.3 minus X. What that mean? What is the minimum number of Y now? The minimum number, because the minimum number of X is 0. So the minimum number of Y should be 0.3 minus 0 equal to 0.3. Or what you think? Or X equal to 1. So the maximum number of X, because we have the inverse sign, the maximum number of X is 1. So 0.3 minus 1 equal to minus 0.7, isn't it? So if we like minimum of Y equal to minus 0.7. And the maximum number of Y, actually now it becomes only 0.3. Okay? Or very close to 0.3. As you can see, 0.2999. Now the number is between 0.2 or from minus 0.7 up to 0.3. Okay. If you want the probability of tail to be 0.7 and the probability of head to be 0.3, then we can define the probability of tail is the negative numbers of Y. Okay, I will do that in very simple way. I will make this, I will define Z now equal to sine. Do you know what is what sine do? Before I do that, let me show you one thing. If you say sine minus any number less than 0, it gives you minus 1. If you put sine any number greater than 0, any number greater than even 0.4, it gives you 1. So here the sine function here gives you the sign of the element. If it is negative, it gives you minus 1. If it is positive, it gives you 1. Okay, so what is sine of 0? It gives you 0. So this is the function of sine. If it is negative, gives you minus 1. If it is positive, gives you 1. If it is 0, it gives you 0. Okay, now if I make sine Z equal to sine of X, Z now will be either minus 1 or plus 1. 70% of Z will be minus 1. And 30% of Z, it will be plus 1, or almost. Okay, so now if you look, I don't want to show all Z because it will be very long, 10,000 elements, but let us take the first 20 elements, the first 20 elements of Z. Okay, I will take transpose to show them in as row. You can see now 20 element of Z, it was all of them, they were 1. Okay, so it was 20 element. Sorry, Z should be not sign X, it will be sign Y, because all X is greater than 0, then the sign of X will be always 1. But now it will be different. So yes. So you can see now it will be, you have -1, you have 1, -1, 1, -1, 1, and so on. So -1 means tail, +1 means head. So when you generate this 10,000 number, it is equivalent that you like repeat as yet that you did it in reality, that you take the coin and you flipped it 10,000 times. But now you did it on the computer by simulation. Okay. Even you can name them like head and tail if you like, for example, but it is not needed. We can just use it with numbers. Okay. So now if you want to calculate what is the probability of tail, then the probability of tail, we can compute them as the length of find of what? Of Z equal to -1. Sorry. -1 divided by the total length of the numbers. So it will be the length of Z. So this gives you the probability that you will get tail. So it is 0.69, 0.6958. So it is very close to 0.7. Okay. And of course, the probability that you get head, it will be this one. Any question? Okay. Yes. If you like, for example, to put head and tail, you like that, for example, to explain to students or to explain to some others that you like to see some numbers there. So you can simply say that, for example, I can call it, for example, H of, for example, in the beginning. So we can say that H equal to Z, for example, and then H of find of Z equal to -1. This is the tail. Okay, this should be equal to tail. Okay, and the same, but for 1, this should be head. Okay, so now H contains tails and heads. So if you write, for example, H character, if you look to H now, you will find that like ASCII code. In the ASCII code, so if from 1 to 10, for example, or 1 to 10, it will give you like an ASCII code. This 84. If you want to see them in as characters, so simply that you can I can call them like H1 equal to character of H. So I can convert them into characters, and that now H1, like the first 20 element, it will be, maybe I would put them like row. You can see that tail, head, tail, head, tail, tail, and so on. So it is now, as you can see them, that as tail and head. If you want to visualize them as like more realistic instead of numbers. So this is the concept. Now, if I throw 3 coins, not 1 coin. Okay. Now I throw 3 coins. And the probability of each coin different than the other. So I will make it a little bit complicated now. So I will generate first, of course, now we have X. X is for the, but let me start from the beginning. If you want to clean it from the beginning, so you can just clear all. Clear all, it will erase everything in Octave. And you start again. Now I will generate the same, but I will generate X number, and this X number equal to random, the same way. But what I will do here, I will generate 10,000 row, but 3 coins. because now I have 3 coins. Okay, and I will subtract each one from the probability that I want to do. For example, let me define the probability vector equal to the first probability is, as we said did before, 0.3 and 0.7. The other one is 0.2 and 0.8. The last one is 0.8 and or maybe 0.6 and 0.4. Okay, so now this is B. This is the probability. I will say that Y equal to X minus, of course, now if we put X minus P, okay, so it will be subtracted from each row. So if you look now to P, Y, if we take the first 5 elements for all columns, that you can see it like this way. So yes. So here it is 0.35. Here is 0.7. Here is minus 0.2, because here it's multiplied by 10 of the power 0.1. So now we got these numbers. Now what I can do here, I like to convert them as we did before, like +1 and -1. Again, I can put it like in this way: z equal to sine of y. If now you look to z for the first 5 elements and for all columns, when you want to show all columns, you don't need to put from 1 to 3. You can just put this one there. Okay, so it becomes this one. What it means here, it means that it is the first throw of the, or the first flipping of the 3 coins, you get head, head, tail, tail, head, tail, head, tail, tail, and so on. So this is now the experiment that you have done. If I asked you a question, okay, what is the probability in this problem that you will get all head? All head. Of course, you can solve it by pencil and paper as we showed before. You can solve it. But now, in this case, we don't solve it. You don't need to solve it by hand, because by simulation, it gives you the approximate of the result. Okay, what I can do, if I asked you, what is the probability that all are head? We know that the probability of head, we said that it should be like 1. Okay, you can do it in different way. You can do it in the way that find z1 equal to 1 and z2 equal to 1 and z3 equal to 1. It is okay. It is fine to do that. But it is easier since we have 3 heads, so the summation of each row must be 3. Okay, then if I define now, for example, another vector, and we call it like sum of z. Okay, by the way, if you want to know the size of any vector, you just write size of c. So now it gives you 1, 3. What it means? It means that it takes the summation like row by row. I want to take the summation vector by vector. For that reason, I will take that CZ transpose. And now, if you want to find the size of C, it is 1 by 10,000. Okay. What is the probability that all of them will be head? The probability is, first, let us define the total number of n is the length of z. Oh, sorry, the length of C. This is the total number. It is 10,000. Okay. And the number of the events that we are looking is equal to length of find of C equal to 3. Okay. So actually, here it gives me that the total number, not C, sorry. should be not X, should be C. Yes. So the total number is equal to 2,269. Then the probability will be NE divided by N. It is 0.2267. You can see now we found the probability that we get all head without solving it. Of course, now you can take your pencil now and you can solve it yourself. And it is not hard to solve this one. But we have in reality much more complicated scenarios where you cannot you solve them by hand. So when you have this strong like tool in your research, you can make a lot of study, and you can have, for example, some ideas in wireless communication that what happens if the channel is a Rayleigh channel and the signal follow this distribution, and then we have moving target, and we have mobile network, we have this interference, we have this reference, much complicated scenario which cannot be solved by hand, and it can be easily solved by simulation. So this is the strong part here. So you can make a lot of things to solve them just by simulation, because when we put 10,000, it means that as you repeat the scenario 10,000 times, of course you can do it more. For example, I can do it more. I can show you one thing here in Octave. It is very important that to show. If you go to the upper corner, to the left corner, you can actually generate a new script here. So instead of working in the command window, you can work in the editor here. So for example, anything you put with the percentage sign, it means that it is just like a comment, so it will not be executed. So this is our first code in random analysis, for example, okay? And now I start with the clear all. So I clean everything there. Then I define the number of repetition of the example. So n equal to, let's say it is 10,000, okay? And it is good when you write code to describe your code one by one. So n is the number of, for example, of repetition, okay? And then I will generate the random number, x equal to random, and I will generate n, the number of repetition, and 3, because I have 3 coins, okay? Don't forget to put the semicolon after every one, because otherwise it will be substituted, it will be executed on your screen, and it will take a long time if you generate like million number or something like that. And then I generate the probability. So the probability, actually you can define them here also. In your example, you can define what is B1 is equal to 0.7 or 0.6, and B2 equal to, let's say, 0.9, and B3 equal to, let's say, 0.1. Okay, and then I can come here and to say that the probability equal to B1, B2, B3. So I define them already. Okay, and then y equal to x minus p, or p minus x, of course, or p minus x. Okay, it depends on where you want to define head and tail. Is it +1 or -1? By the way, it is not necessary to be head and tail. I just take this flipping of the coin for simplicity, so you can say that it is happening blackout or not happen. Okay, it is faulty or not fault. Is it, for example, the patient has this disease or that disease? So you can generate it. It is not just head and tail. Just we put this example to have like two cases, and you might have different cases, by the way. Not necessarily that it will be only 1 and -1. It can be different levels, as we will see. This is only for Bernoulli like distribution, as we will go later, inshallah. So now y equal to b minus x, and then I call z equal to, or z equal to sine of, so all the steps that we did, sine of a y. Okay. There is a question on chat. I will come to it just a minute. So it is sine of y. Then if I want, what is the probability that all outcomes are 1, then as I said, so we can compute that NE equal to, for example, length. Okay, in the beginning, that, as I said, that we need to take the summation. So we take that C equal to sum of C. Okay, I take sum like not row by row, but vector by vector. Sorry, this should be not C, but any other number, maybe n small. Okay, and then yeah, so we can compute the probability that all are 1, NE equal to what? Length of find of n equal to 3. Then the probability BR equal to NE divided by the total number n. Okay. When you complete the code, of course, we might have bugs here. So we will check when we execute the code. But before you execute the code, you need to save the code. So you can come here and to save it. So you can save it with any number, for example, or any name. For example, first code. First. Okay, first code. Save. Now I substitute it here. So I substitute. So we check if it is correct, or we have yes, error C undefined. Okay, they say that C is undefined because yes, because here we use shouldn't be C, because this is the sign, so this should be actually Z. Okay, now we try again, save, and try again. Okay, so now this probability, the probability is 0.047 in this case. Now let me check your questions. Yes, there's one question, B1, B2, B3. The question that what we mean by B1, B2, B3. Good question. Actually, this is yeah. Let me go back to the code. Okay. Editor. Yes. So now, if we look to this, what 0.6 means here? What I'm doing here, I am subtracting 0.6 from number from 0 from x from 0 to 1. Okay. So here 0.6 is the probability that you have +1. You can define what is +1 up to you, because as I said, now it is 0.6 here, and 0.6 minus random number from 0 to 1. If x equal to 0, then it will be 0.6. If x equal to 0.1, it will be 0.5. If x equal to 0.2, it will be 0.3. Up to x equal to 0.6. 0.6 minus 0.6 it will be 0. And if x equal to 0.7, 0.6 minus 0.7 equal to minus 0.1. So when you go to the minus sign, when you take this sign command, as you can see it, it will be -1. And if it is positive, it will be +1. Okay, so B1 is the probability that you will have +1. And 1 minus B1, it will be the probability that you will have -1. What +1 mean and what -1 mean? It is up to you. It is up to your application. If you are doing applications based on flipping a coin, it will be head and tail. And then you can define the head is +1 and tail is -1, or the reverse. It is up to you. You can define, for example, this could be the probability of having blackout in 3 different countries. So one country, they have blackout 40% because +1 means that there is no blackout, and -1 is there is blackout. Then B1 is equal to 0.6, means that blackout is 0.4. In the second country, the blackout is 0.2. In the third country, the blackout is 0.9. For example, it can be patient disease. It can be anything. You can define what the numbers mean. Okay, but here B1, B2, B3 means that the first event, the probability that it will be like +1 is 60%. To be -1 is 40%. B2 is the probability that to be +1 is 0.8, 80%. To be -1 is 20%. Here, the probability that to be 1 is 10% and to be -1 is 90%. Okay, what I want to see here, I like to see what is the probability that all of them are 1. So this probability, you can do it yourself. You can try it yourself. But here, the probability that all of them, they are 1, okay, when I made it with this Monte Carlo simulation, it gives me this result. I can repeat it again. So if I repeat it again, so you can see the result is 0.047. And you can change n. You can, for example, here I used n 10,000. I like to use, I like to repeat it 100,000, for example. I just add here 0, and then I made it. So I got even more closer result to the reality. So we can get like 0.048. Okay, so now this is B, or in the code, it is 0.6, 0.8, and 0.1. If I asked you by calculation, what is the probability that all of them, they are 1? Of course, it will be the probability that the first one is 1 because they are independent. They are independent. And since they are independent, so that the probability, as I show now, that probability of A and B equal to probability of A times probability of B if they are independent. And since they are independent, then it will be like 0.6. It will be 0.6 times 0.8 times 0.1. And the result, it will be 0.048. This is the actual result. This is the mathematical result. And this is the simulation result, 0.048. So the simulation results gives you the very close to the reality. Now, I can go to complicate the example. For example, if there is a condition here, if the events, they are not independent, but they are dependent. If the conditions, they are dependent. Okay, so how this will affect the probability? Of course, now when they are dependent and you want to solve it by hand, analytically, it is not that easy actually. And we will see some examples when they are dependency between them. But in the simulation, you can just simply use as much as you like. And as you can complicate it as, for example, assume that B2 is 80% of B1 times B1. So depending on B1, we will get like B2. Okay, or maybe it is even dynamically more complicated. For example, what happens if I will make, for example, for the second or for the third one, it will be 1 if the previous 2 were 1. Otherwise, it will be -1. For example, this makes it more complicated. And if you want to solve analytically, it is still straightforward, not very hard to solve it, but it is not very simple. But in simulation, you can complicate it as much as you like. There is no problem in the simulation. So simulation is, of course, we are going to revisit the simulation many times in the course. But what I want from you after this lecture, that you try yourself to practicing this one. I will send you, to all of you today, the first pages of my book about uncertainty and simulation and modeling. In my book, we have also different examples also with by simulation, so you can practice them. And we have also many numerical example, so you can try with all of them. Okay. Let me check if there's questions in the chat.
But give us time to try this program because it's the first time we use it.
I couldn't hear you very well. Maybe if you can write the chat.
Yes, but you give it the time to use to deal with this program because it's the first time we deal with it.
I cannot hear you, Sabri.
دكتور يعني انت تعطينا وقت يعني نديروا تراينج للبروجرام قبل ما تعطينا الاكزامبل.
No problem, of course. What is coming, inshallah, it will be more time. But today, just I introduce you to the coding, okay? And as I said, maybe I will show you the book that I wanted to distribute with you. Just a minute. I will stop share this one. So maybe now you can see the this book. So in this course, we cover only the second chapter. Of course, the first chapter is the introductory part, but and if we have time, then we can also cover the third chapter. But you can see here the explanation of probability theory and also some I just so you can see here that almost very similar to the slides that I sent you, but here you will have more examples. This code is written by Scilab, Science Lab, but you can ignore the codes with Scilab. You can, in this course, it is enough that you learn the Octave. It is very similar, but they are very similar, by the way. Scilab is also similar to MATLAB, but not identical like Octave. And here there is the explanation of yes, the Octave code, and you can see here that the conditional probability. This is what I was explaining today. Okay, some more examples. So there is one example here. It is already also given in the slides, but it is explained here in details. And then also the code, how to solve this example. another example about cognitive radius. This example related to cognitive radius and the possibility of crash between cognitive radio and a radar system, and also how to solve the problems with using Bayesian theorem, and then how to make Octave code to solve the same problem, and then we compare the results obtained by the code and also by the analytical solution, and the examples are given in details. I mean, you can just use another example. For example, a blood test method is employed to detect a specific disease, boasting an accuracy of 99%. However, it does yield 1% false positive rate. Historical screening data reveals that only 1% of the population is afflicted with this disease. So now how to, and we take one random sample, what is the probability that this sample has this disease? So now we show how to solve it, and also by simulation and by calculations. So you will see a lot of examples in the book. I will send you the pages related to this part. Okay. Before that, I like also to give you just few for those who like to see also Scilab. It is also free, and you can find it on Google, so you can. Yes. Yes. Yes, this is it is called it is Scilab, SCI Lab, scilab.org, I think, or .com. If you like write Scilab, you will find. So this is the last version, or the last available version. It is also open source and it is free. It is also similar to MATLAB. They the nice thing in Scilab, you can see here, if you control application, here they have actually translator MATLAB to Scilab. So if you have, for example, a code you wrote before using, for example, MATLAB, you can transfer it to this Scilab. Okay, and here, if you write just see. I will now, maybe you don't see it, but I will put it on the screen, and just a minute. I need to show the screen, not the application. Screen 2, yes. Now you can see the whole screen, not only the application. So here you can see this is the XCOS. It is very similar to Simulink. For those who are working with Simulink and they are familiar with Simulink, they can use this in Scilab. In Octave, they don't have this. So for example, you can have a linear system, as you can see, and then you can have here, for example, the oscilloscope. Yeah, and with the mouse. Can have clock for the oscilloscope. You might have, for example, step function. Just a minute, I have. I have a problem with the mouse. It cannot. It seems that the battery of the mouse is dead, so that's a problem. You can see this is the outcome. Mhm. So you can control. For example, you can put plus s square, and here you might put, for example, minus s. Okay, and then you can see what will be, how will be the simulation result. So it will be divergence and so on. Actually, you can build any controller or any linear system. You can see here in the system continuous and time discontinuities, discrete time systems, lookup tables, mathematical operations, matrices, electrical. So you can have voltage, ground, inductor, ideal transformer, and so on. So they have a lot of nice like features here, but I should say that it is not like comparable with the Simulink of MATLAB. It is, of course, Simulink in MATLAB is much more powerful, but still the nice thing here that it is absolutely free. So you can use it and you don't feel that that you can use all features here. And at least for our study and our master study, it is more than enough. Okay, I think it is enough dose today. I will just go to the slides. Where are the slides? Yes, they are here. And yes. So maybe you can see here that, yeah. So we have already, this is example about few examples. So I encourage you that you study these examples very well, and the solutions also are given in details here. And today, I don't know how much time that you still have, uh, but if you have 1 hour, because actually I didn't give you any break because we started already late. We will have a quiz. In this quiz, not necessary to do it today. If you can arrange with Dr. Farhat, so he can arrange the quiz for you another time. I will send it now to the email of Dr. Farhat. So if he likes to arrange it for today, it is okay. For another time, it is also okay. The first quiz is consists of 3 parts. The first part is like correct or not correct, true or false. The second part is something related to this set theory, like A and B, A or B, those things. And the third part is a review for mathematics. So I wanted to see your background in general math. So this is the purpose of this quiz. I mean, instead of the first 2 parts, the other parts is just to see your background in like in analytical mathematics, because this gives you some vision how I can also manage the rest of the course. So it is good to know your background in mathematics. So this will be seen in the quiz. The quiz can be done within like maximum 1.5 hours, but it is up to Dr. Farhat that he will set the time when he see the quiz, what is the required time for the quiz, and you can arrange with him, okay, about the quiz. I think this is all from my side for today, inshallah. What I wanted from you that you try to be familiarize yourself with the Octave, and they are like some of those nice functions like random and find, length, size, multiplication of vectors, multiplication of matrix. Try to be familiar with those functions, because we will use them in the coming lectures, inshallah. Because every like mathematical or a probabilistic technique that we give, we try also to show how to handle it with Monte Carlo simulation. Okay. That's all from my side. So any questions you have?
شكرا دكتور. Thank you very much. شكرا دكتور.
I will send inshallah now the quiz to Dr. Farhat, inshallah. I was it just right now, and then you can arrange with him if you wanted to have it today or another time. I have no problem. Also the time, Dr. Farhat, you are free to set the time according to the content of the quiz. So 1 hour, 1.5 hours, 2 hours. I have no restriction for that. Okay.
Okay.
Thank you very much. Assalamu alaikum wa rahmatullahi wa barakatuh.
السلام ورحمة الله.